Welcome to the Walton Pi. Today we're going to be talking about partial fractions and how we might be able to use it to solve some calculus problems. Let's suppose that we are trying to rewrite the fraction 1 over x plus 1 x minus 7. Partial fraction says that we can break this up into fractions where we add them up with each part of the denominator represented once. So we can write 1 over x plus 1 times x minus 7 as something over x plus 1 plus something over x minus 7. The rule for partial fractions is that the numerator is a polynomial of 1 degree smaller than whatever the denominator is. So in this case, because both denominators are linear, that means they have order 1, so they have x to the 1. We need the tops to only have x to the zeros, or in other words, just to be constants. So that means we can put unknown constants there, and we can then try and solve for a and b. Now there's two ways to go about solving this. The first one is the most general form that is going to work every single time. So if we multiply everything by this entire denominator here, so if we were to take everything and multiply all by the denominator on this side, we'd multiply everything by x plus 1 times x minus 7, and then we would expand it out and see what we get. So we are left with a 1 equals a times x minus 7 plus a b times x plus 1, or in other words, ax minus 7a plus bx plus b is equal to 1. So if we were to rewrite that, that means we have 0x plus 1 is equal to a plus b times x plus negative 7a plus b. We can then pair up the matching terms, so 0x must be equal to a plus bx, and then 1 is equal to negative 7a plus b. So we have a plus b equals 0. This is from our x term, and then from our constant term, we get that b minus 7a is equal to 1. So for the a plus b equals 0, we now have, and the b minus 7a equals 1, we now have a system of equations with two variables and two unknowns. We can try and reduce this by solving for one variable. So for example, this bottom one we can solve to say that b is equal to 1 plus 7a. So then we can take that and plug it into the first one, and that's going to give us that a plus 1 plus 7a is equal to 0, or 8a plus 1 equals 0, or in other words, a equals negative 1/8. So if a is negative 1/8, then b is going to be 1 plus 7 of those, so b is a positive 1/8. So now that we have those values, we can then replace those into our equation. So that means we know that 1 over x plus 1 times x minus 7 is equal to negative 1/8 over x plus 1 plus 1/8 over x minus 7. Now we might be wondering, why would we want to be doing this? Well, suppose that we were given the integral of dx over x plus 1 x minus 7. We can't integrate that directly because we don't really know how, but we can use partial fractions to rewrite this into the integral of negative 1/8 over x plus 1 plus 1/8 over x minus 7 dx, which is equal to negative 1/8 the integral of dx over x plus 1 plus 1/8 the integral of dx over x minus 7. And each of those we can integrate using a simple u substitution. So this one we would use u equals x plus 1, du equals dx, and this one we would say u equals x minus 7, du equals dx, and this integral will turn into negative 1/8 natural log of x plus 1 plus 1/8 natural log of x minus 7, and that is how we are able to integrate this with a plus c. That is the integral of this. So partial fractions allows us to be able to figure that out. Now, partial fractions can be a little bit more complicated than that sometimes. So if we were to have something like 1 over x minus 3 times x squared plus 2, this is going to give us a something over x minus 3 plus a something over x squared plus 2. The reason that this is going to be a bx plus c on the top is because the bottom is a quadratic, so the top has to be 1 degree smaller. And so once we have this, we would just set up the same sort of system of equations, multiply everything by x minus 3 times x squared plus 2, and we would end up with a system of equations similar to the first one. Now, this situation where the top is a bx plus c, that is the reason that my other method would not work. So let's go through my other method so you can see why it would not work in this case. So the other method, let's go and do actually the same problem we had before. So we have 1 over x plus 1, 1 over x minus 7. 1 over x plus 1 times x minus 7. We can say that this is equal to some constant a over x plus 1 plus some constant over x minus 7. Now, this method says that this denominator, this is a linear term. That is something that can be equal to 0. So let's just try and solve for a. We are going to multiply everything by just the denominator of a. So x plus 1. So that's going to give us 1 over x minus 7 equals a plus b times x plus 1 over x minus 7. And now we can plug in when x plus 1 equals 0. So that means we are plugging in x equals negative 1. So that means that we get a 1 over negative 1 minus 7, that's a negative 8, is equal to a plus b times 0 over negative 8. So this is just equal to a. So in other words, a is negative 1/8, which is the same thing we found at the beginning. If instead we were to plug in, if instead we had plugged in x minus 7, that would give us 1 over x plus 1 is equal to a over x plus 1 times x minus 7 plus b, because the x minus 7's canceled on the bottom. And so then we would plug in when x minus 7 equals 0, or in other words, when x equals 7. So then we would get 1 over 7 plus 1, that's 8, equals a over 8 times 0 plus b. So this is just b, so b is positive 1/8, which is the same thing we found in the first case. Now, the reason that this method isn't going to work super great on this other problem, it would work to be able to solve for a. So we could solve for a by multiplying everything by x minus 3 and plugging in 3. However, it's not going to work for this because this denominator cannot be 0. So because that it can't be 0, we can't use that method to solve that part. Now, partial fractions is going to be the same sort of method where you go through and do this long process no matter what the function is. So if we were to give something like 3x cubed minus 4x squared plus 2x plus 7 all over x minus 3 squared, x plus 7, x minus 4, x squared plus 1, for example. If we were to try and write down what this would be expanded, this is going to be, we just take each term. So we have x minus 3 squared, we have x plus 7, we have x minus 4, and we have x squared plus 1. What we are going to be doing is, for each of these terms, we are just going to be putting on the top a polynomial that is 1 degree smaller. So x minus 3 squared, that is a quadratic, so the top is going to be a line, so that gives us an ax plus b. The x plus 7, that is a line, so we get a constant on the top. X minus 4 is a constant. Whoops. And then x squared plus 1 is a quadratic, so we get another line. So we get ex plus f. So we're going to have to go through and solve for 6 different variables. So we could multiply everything by this entire denominator, get a system of 6 equations, and then solve for them. Or what we could do is we could shortcut that by doing our shortcut method on these 2 problems. So for example, and then we would still have to do that first method where we multiply everything all the way out and then solve for those values. And so that method can be shortened. If we can solve for c and d first, that's going to reduce the number of variables we're going to have to solve in our system of equations. So if we were to solve for c, what we would do is we would multiply everything by x plus 7. And so that would mean that this term would get canceled, this term would get canceled, but then everything else is multiplied by x plus 7. So then if we were to plug in when x equals negative 7, we would then be able to solve for what c would be, and then similarly for d. Now, that's going to take quite a bit of time, so I'm not going to walk through it, but that would be the process we would go through and do. Also, a common thing that you might see is with this sort of situation where we have an x minus 3 squared, sometimes, depending on how you're learning partial fractions, this is broken up into something over x minus 3 squared and another thing just over x minus 3, where both of these tops are constants. So the rule is saying that because it's the quantity x minus 3 that is squared, we can break that up as x minus 3 itself is linear, so the top could be a constant, but then we have to have a different piece representing each of the powers. So for example, if instead of being like x minus 3 squared, it had been x minus 3 to the 4th, so if we were given something like 1 over x minus 3 to the 4th, x plus 2, this would give us something over the x plus 2, but then we are going to have something over x minus 3 squared, x minus 3 to the 3rd, 3 comes after 2, and then x minus 3 to the 4th. We would be able to write this with constants on top of each of these, because we go through each of the powers. We go through 1, 2, 3, 4, all the way up until we reach this point. That's another common way that you might be able to see this. And so this is another way that you might see partial fractions in the future. But that's how we would go about solving these partial fractions, and all of them can be shortened usually using this shortcut method where you just plug in the value at different points, and then the other ones can be solved by going through and doing this long process of getting a system of equations and then solving for the different values of the variables. I hope you enjoyed this video and that it was helpful for you. Please check out some of my other videos, and please like and subscribe if you have not already so I can continue to make these sorts of videos. Have a great day and good luck with the rest of your math.